3, 2, 1. Engines full power. And liftoff of Starship.
Going to space is expensive. You probably don't need me to tell you that, but what I can tell you is that there is a complex process hidden behind that rocket launch, a journey that most people have never considered. It crosses America from sea to sea. It involves hundreds of incredibly skilled individuals working thousands of hours over weeks and months of preparation. It demands the highest levels of scientific innovation and technical engineering. And there is no better example of this than the SpaceX Falcon 9, a rocket that launches every other day, delivering hundreds of tons of payload and people into Earth's orbit every year. Going to space has never been easier than it is on Falcon 9, but that still hasn't made it cheap either. So where does all that money go? Okay, the first and most expensive step in getting to space is obviously building our rocket. There are three main components that make up an orbital rocket: the booster, the upper stage, and the payload fairings. The booster is the largest and most expensive of the three, accounting for between 60 and 70% of the entire rocket's cost. Now, in the case of the SpaceX Falcon 9, there are two roads we can travel. The high road is building a new booster from scratch. The low road is refurbishing an existing booster that has already flown to space, and we are going to see how this refurbishing process is the key to the SpaceX business model. But we'll start by taking the high road. A Falcon 9 booster is powered by 9 Merlin 1D engines. These cost about $1 million each. The Falcon's body is made from a unique metal alloy of aluminum and lithium, and then there's the landing hardware, 4 extendable legs made from carbon fiber costing between $50,000 and $100,000 each, paired with 4 aerodynamic grid fins made from cast titanium at a cost of between $200,000 and $300,000 a set. There's also white paint, which might sound trivial, but when we're talking about a product this big, that's a lot of paint. All in, the cost of a new booster is going to range between $30 and $40 million. Moving on to the second stage, this part of the rocket is expendable, and a new one has to be built for every launch. There's a lot less involved in an upper stage, just 1 Merlin engine, a relatively short lithium aluminum body, and a payload adapter. SpaceX keeps production cost at a minimum by using economies of scale. The company built over 140 upper stages in 2024 at a price of $10 to $12 million per launch. And then there's the payload fairings, clamshell-shaped panels that make up the nose cone of the rocket and protect the payload during ascent through the atmosphere. These look simple, but there's a lot of work that goes into making them. The outer skin is made of high-grade aerospace carbon fiber sheets, which provide rigidity and strength. Those are reinforced by an aluminum honeycomb structure that helps maintain the fairing's shape and stiffness while minimizing weight. And there's a layer of cork in between that provides thermal insulation and impact protection. The fairings are built tough because they're also reusable, just like the booster stage. After the fairings break away and fall back to Earth, they splash down into the ocean, and SpaceX will recover them with a special boat. That sounds like a lot of work, but at a cost of roughly $6 million for a new set, it's worthwhile going to fetch them. That brings the total cost of our freshly constructed Falcon 9 to somewhere between $50 and $60 million. Now, here is where things get interesting. All of this rocket hardware is built by SpaceX in Hawthorne, California. That is a suburb of LA, and most rocket launches happen at Cape Canaveral in Florida. That's on the total opposite end of the country. So how do they get there? One of the design considerations with Falcon 9 was that it had to stay small enough to be transported on the road. Bigger rockets can face extreme transportation challenges. They need to be floated on barges, sometimes all the way down through the Panama Canal and back up again. Otherwise, they need to be loaded into highly specialized transport airplanes. SpaceX is all about minimizing cost, so they ship their rockets on trucks. The Falcon 9 is transported in segments. The first stage booster is about 140 feet long with its legs folded. The second stage is shorter, around 40 feet, and the payload fairings are shipped as two halves, each roughly 43 feet long and 17 feet wide when packed. The components are wrapped in protective coverings and loaded onto custom trailers to shield them from weather and road debris. From Hawthorne, the Falcon 9 convoy heads east through California, Arizona, New Mexico, Texas, then down to Florida, a trip of about 2,700 miles if they don't hit any detours. The journey takes between 4 and 7 days depending on stops, permits, and weather. Speeds are limited to a maximum of 50 miles per hour due to the load's size and weight. The booster alone weighs around 50 tons when dry. Managing a convoy like this is no small task. You don't just cruise across the country with a rocket on your truck. Oversized loads require state-by-state permits, pilot cars, and sometimes temporary road closures. Of course, none of this is cheap. When accounting for the cost of the trucks, fuel, labor, permit, tolls, equipment, and insurance, the cost of transporting a full rocket is going to come in at around $150,000. Though in the context of building a rocket, transportation is a relatively small expense. The 7-day cross-country trip only costs about 1/10 the price of a single Merlin engine, which is why SpaceX opts to recover and reuse their boosters as much as possible. Now, this is still not cheap, but it is much less expensive, and here is what that looks like. The most common landing for a Falcon 9 is going to be out at sea on the platform of an autonomous drone ship. SpaceX has 3 of these ships, and they've been using them since the very first booster landing attempts, so they've already paid for themselves many times over. On the deck of the ship is a robot called the Octograbber. It's going to secure the booster as it sails back to port. When they arrive at Cape Canaveral, a SpaceX crane is going to offload the booster from the ship and onto a truck, which will carry the rocket a short distance to a SpaceX facility called Hangar AO on Roberts Road at the Cape. The cost of returning the booster from sea is typically between $10,000 and $20,000 depending on weather conditions, which might sound like a drop in the bucket at this point, but all we've really done is get the rocket back from the water for the price of a used Honda Civic. Inside the hangar, the booster is first given a visual inspection by technicians who are looking for damage and wear to the heat shield. The base of the booster has an ablative coating of heat-resistant material. Ablative means that it's designed to wear away as it's heated, so any areas with erosion on the heat shield need to be patched. The 9 Merlin 1D engines are inspected for soot buildup, turbine blade cracks, or injector wear. There's also a data review after every flight. Onboard sensors log stresses, temperatures, and vibrations, feeding into a diagnostic report. If issues with the engines are flagged, they get removed and partially disassembled. SpaceX uses borescope cameras to check inside the engine without having to do a full teardown. It's like a colonoscopy for the rocket. Just like the engine in your car, the Merlin is going to need periodic maintenance. It's typical to replace seals, gaskets, and turbine blades between flights, but in the case of major damage, a whole engine might get swapped out. The fuel tanks are depressurized, drained of any residual fuel, and then cleaned to remove any contaminants. Landing legs are checked for cracks or hydraulic issues, grid fins are inspected for dents or heat warping, and meanwhile, the exterior of the rocket gets hosed down with a pressure washer to remove the loose soot and char from re-entry. And then they put it all back together again. After reattaching the legs, grid fins, and engines, the booster is returned to the launch pad for a static fire test to ensure that everything is working as expected. And because SpaceX has so many boosters in their rotation, it's likely to get shelved in Hangar AO for a while until being assigned to a new mission. This turnaround time can be as fast as 27 days, but the typical process is between 1 and 3 months before a booster is back in action. The exact cost of a booster refurbishment is hard to nail down, and it really depends on how much work is required on each specific job. But industry sources have put the cost somewhere between $250,000 on the low end to as much as $2 million on the high end. Now compare that back again with the $30 to $40 million required to build a new booster from scratch and the economic advantage of a reusable rocket becomes pretty clear. And now that we have all of our rocket components prepared for launch, it's time to integrate the two stages and the payload into one complete vehicle. SpaceX uses a horizontal integration facility located at their launch pad, meaning that the entire rocket is built while on its side. The first stage is rolled into the HIF and placed on a stand. The technicians then connect electrical and fluid lines. The second stage is hoisted by a crane and aligned with the booster's interstage. That's a black carbon fiber structure that allows for stage separation in flight. The two are bolted together and linked by umbilical connections for power and data. The payload is connected to an adapter and enclosed in the rocket fairing. This happens in a clean room to avoid contamination. The encapsulated payload is moved to the integration site, often on a specialized trailer under controlled conditions. The payload is then lifted and attached to the top of the second stage. The final step inside the facility is to integrate avionics systems like flight computers and sensors, then test them to confirm communication between stages and payload. With all systems checked out, the fully assembled Falcon 9 is loaded horizontally onto a mobile platform, and it's driven a short distance to the launch pad, just over 1 mile away. Once Falcon 9 arrives at the pad, the mobile platform will use its hydraulic system to lift the rocket to a vertical position, aligning it with a support tower called the strongback. Once it's up, clamps secure the rocket and umbilical lines are connected to the launch tower for fuel, power, and data. This whole process of integrating the rocket and getting it to the launch pad takes between 1 and 3 weeks depending on the complexity of the payload. Simple Starlink payloads would be closer to 1 week, while a NASA mission with the Crew Dragon will take closer to 1 month of preparation. Given that SpaceX is able to launch at least one Falcon 9 every 3 days, it shows that their integration process is highly optimized, with multiple rockets being prepped all at once. So by factoring in the cost of labor for a crew of between 50 and 100 technicians, engineers, and support staff, rent paid to NASA for the use of their hangar and clean room, equipment costs for the cranes and transport vehicles, plus all of the single-use hardware associated with securing the payload, we'd be looking at an average cost right around $1 million to assemble a rocket and put it on the launch pad. Now it's time for the rocket fuel. Falcon 9 uses two kinds of propellant, RP-1, which is rocket-grade kerosene, and liquid oxygen, which is just oxygen that's been made really, really cold until it's dense enough to blast a rocket into space. The Falcon 9 booster takes around 410 metric tons of propellant. The ratio is about 75% oxygen to 25% kerosene. The upper stage needs around 95 metric tons of propellant with the same 75-25 ratio. So that's just over 500 metric tons of propellant for one single rocket launch, which is the equivalent mass of 10 blue whales. So where does it all come from? Well, RP-1 is a highly refined fossil fuel that's derived from petroleum oil, just like gasoline, and it's made by the same suppliers that you might see at your local gas station, like Chevron or ExxonMobil. The cost of RP-1 is also pretty similar to gasoline, about $1.50 per liter. There are only a few refineries that make RP-1 though, and the closest to Cape Canaveral would be in Houston, Texas. RP-1 is transported in stainless steel tanks pulled by semi-trucks. You need 5 truckloads to fill one rocket, and that convoy travels about 1,000 miles to reach the launch site. Meanwhile, liquid oxygen is produced by air separation units, which cool air to negative 195 degrees Celsius. That makes it pretty cheap compared to RP-1 at only about 25 cents per liter. Given that liquid oxygen has been used in every rocket launch since the 1960s, there are established ASU sites right near Cape Canaveral. The liquid oxygen is shipped in vacuum-insulated cryogenic tankers, and SpaceX needs about 15 truckloads delivered per launch. That puts the total cost of delivering fuel for one rocket at about $350,000. And there's another vital liquid involved in launching a rocket: water. Hundreds of thousands of gallons are pumped into the area directly below the rocket engines in the moments before ignition. The water deluge works to absorb heat and energy from the rocket exhaust, but it also does an important job of dampening the noise of the engines, which can create vibrations so powerful that they would damage the rocket, the payload, and any nearby structures. The launch pad is surrounded by water, but that's not what gets used by the deluge system. Each launch complex has its own giant water tower. Falcon 9's is 300 feet tall. It was originally built for the Apollo moon missions back in the mid-60s and holds up to 400,000 gallons. The source of that water comes from the city of Cape Canaveral. City water is drawn from the Floridan Aquifer, a massive underground reservoir. So by comparison to everything else involved in a rocket launch, the water deluge might look extreme, but it's actually cheap and easy. Even when you factor in the electricity to run the massive pumps and cost of maintaining the plumbing system, it's just about $1,000 per launch. So with that, we can start adding up our total cost to fly one Falcon 9 rocket into space. There's the rocket itself, that's always going to be the most expensive part, and assuming we've used a refurbished booster, the average cost of the Falcon 9 is going to be $21.5 million from top to bottom. The cost of transporting the hardware from California to Florida is about $150,000. The integration process is $1 million, the fuel expense $350,000, water and electricity bills add up to $4,500. Then we also have to factor in the administrative cost of obtaining launch licenses and submitting environmental reports. That would average around $250,000 per launch. There's also a staffing cost for every employee at SpaceX involved with the launch process in any way, from ground controllers to live stream operators and floor cleaners, around $2 million on average per launch there. Maintenance of the concrete launch pad itself works out to around $125,000 per launch. And then there are company overhead costs on all of the equipment and facilities, plus research and development work that goes into making an operation like Falcon 9 possible, about $3.5 million per launch. So when we add that up, we get a total average cost per Falcon 9 launch, and that comes to right around $28.9 million. And that number just so happens to line up pretty damn close with what SpaceX Director of Vehicle Integration, Christopher Couleris, told reporters in the year 2020. He said that Falcon 9 cost $28 million to launch it. That's with everything. In the 5 years since then, there's been a lot of inflation, but SpaceX has also ramped up their launch frequency by a significant amount. In 2020, Falcon 9 flew 26 times. By 2024, the company hit 132 launches in a year. So economies of scale can be very powerful at mitigating price inflation. Which brings us to another important point. We've figured out what it costs SpaceX to go to space. So when you see one of their Starlink missions, now you know the price they paid. But how much does a SpaceX customer pay to put a payload into space, and how much money does SpaceX make? For one dedicated Falcon 9 launch with a maximum payload mass of 22 metric tons, you are going to be paying between $70 and $75 million, giving SpaceX an approximately 60% profit margin and putting somewhere in the range of $40 million in their pocket. Now, there is a cheaper way to get your items into space as long as it's relatively small. SpaceX rideshare missions on Falcon 9 deployed dozens of small payloads from multiple customers. To hitch a ride on this flight, you'd be paying $6,500 per kilogram of payload. If SpaceX maxes out Falcon 9 on one of these rideshare missions, they can make as much as $80 million in one launch, about a 74% profit margin. And the most expensive trip to space is when you send human beings. A Crew Dragon mission with astronauts on board is going to cost NASA up to $150 million, which sounds like a lot of money, but this number actually highlights just how cheap Falcon 9 really is. When NASA launched their astronauts on the space shuttle, that would cost them $1.5 billion per launch. When the shuttle was retired and NASA switched over to buying seats in the Russian Soyuz capsule, that would cost them $86 million per seat. So getting 2 astronauts to the ISS was $172 million and involved being totally reliant on a foreign power. The SpaceX Falcon 9 has made space accessible in a way that was previously considered to be impossible. By relentlessly pursuing reusability with their rocket booster, SpaceX was able to break down the strongest barrier: cost. Now, that still doesn't mean that going to space is cheap, but the cost is moving in the right direction. And with their next big rocket project, the Starship, SpaceX has a new opportunity to change the game all over again.